Hello, I'm Richard Goering, and we're here at the Design Automation Conference 2011, and I'm speaking with John Heinlein, who is Vice President of Marketing for ARM's Physical IP Division. Now, John just gave a keynote speech for the IP Talks session here at the ChipEstimate.com booth. His speech titled, Enabling Smarter Systems to Accelerate Innovation. So, John, the first thing I've got to ask you is, what is a smart system? What is smart system design?
I think smart system means a couple of things. One is if you look at the devices we're all using today, things like smartphones and advanced devices, we expect a lot more from them. So part of the issue is the devices themselves are getting smarter. The other issue is they're becoming more complicated. So I think we have to be smarter about the kinds of technologies and pulling together the many technologies that make these devices. And so what I talked about today is some of the things ARM is doing to make those challenges easier for our SoC designers.
Now, you talked about the Internet of Things as being kind of the next step in computer-based design. What is the Internet of Things? What's an example?
Well, we see connectivity coming in lots of places. Think about smart meters. Your house has now, or probably will soon have, a smart meter with an IP address where they can literally talk about your power consumption versus your other neighbor's power consumption dynamically and help balance power. I think you can see sensors around the world. I'd like to think that as I'm driving home, my refrigerator would send me a message that says I'm low on milk, and since I have a baby daughter, that's an important thing to make sure I have milk.
Yeah, very practical stuff. You also talked about the importance of microcontrollers in this new Internet of Things. You know, that's kind of a thing. Microcontrollers have been around forever. What kind of role are they going to play in these highly mobile, low-power devices?
Well, one of the things we're seeing is that more is being demanded of microcontrollers than ever before. By having more advanced microcontrollers that you have richer software, you can do things like power efficiency. I talked about motor control. If you're applying power to a motor when the spinning rotor is at the right position, you actually save a substantial amount of power. Things like smarter air conditioning, smarter power management, like the smart meters example. So microcontrollers plays a role in a lot of energy saving and a lot of value-added services that we expect from these devices.
Okay. Now, when we get to the Internet of Things, one thing you mentioned is that the criteria really shifts from power to energy. How are you differentiating those two terms?
Well, power is about how much energy is consumed at this moment. Energy is about how little energy can I use in total to accomplish a task. And if you've got a power-constrained environment, especially a battery-operated environment, what power you consume is really irrelevant. It's how much energy from the battery do you consume to get the job done. And so we need to think about an energy efficiency in general, not just about power at any one moment.
Right. Okay, now you talked about several new things that ARM is doing to help enable this new era of design. One of them is called processor optimized packages.
Right.
How do those work?
Well, our customers are demanding a lot more from ARM cores in these advanced applications. And at the same time, the need for fast time to market hasn't gone away. So what we're trying to do is produce the optimizations, all the optimizations you need to make an ARM core efficient and fast time to market in one place. It's optimized physical IP that helps customers get the high performance points. It's reference information that tells them how fast we think the core can go in different process technologies, and guidelines that help them achieve that same results. We're rolling this out across a range of ARM cores and a range of process technologies spanning TSMC, GlobalFoundries, and Samsung at 40 nanometer and below. It's very, very popular, and we're seeing customers getting great results and fast time to market.
Okay. You also mentioned today's announcement of the AMBA4 ACE protocol, which has to do with hardware cache coherency. Who needs this capability?
As you're getting into these smart systems, especially multi-core design, adding graphics, video engines, and so on, cache coherency is a must. In the past, you may be able to get away with that in software, but we believe hardware coherency at these high performance points is mandatory. And what the AMBA spec, the ACE spec we've rolled out today does is provide a consistent framework for our partners to implement coherency in their modules that they can plug in. We've also rolled out some specific implementations of that spec that customers can use if they want, or they can implement their own modules that plug in consistently.
And then finally, you're launching a new SoC community today. What's that about?
Well, it continues on this thing I mentioned where there's many different technologies needed, from the processor to the physical IP to the system IP. And so we wanted to put one place on ARM.com that SoC designers can go on an ongoing basis to get news, information, technology updates, training, webinars, opinions from ARM experts as well as industry experts at large, and they can come back to that will really improve their own SoCs.
Okay, well thank you, John.
Nice to talk with you.